The law of cosines yields an interesting result for geometry. That is, a formula for the length of a chord on a circle. Recall that a chord on a circle is simply a line segment with both endpoints on the circumference of the circle. If a chord of length A subtends a central angle alpha in a circle of radius r, then the length of the chord A is equal to r times the square root of 2 minus 2 cosine of alpha. We can easily derive this formula using the law of cosines. Observing this triangle formed by two radii of the circle and the length of the chord A, we see that we have a triangle with angle alpha. Isolating the segment A and squaring it, this is equal to the sum of the squares of the other two sides, that's r squared plus r squared, minus 2 times the product of those two sides, that's r, times cosine of the angle in between, which in this case is alpha. Simplifying, we have a squared equals r, or let's call that 2r squared, minus 2r squared cosine of alpha. Now, looking at that, I know that the 2r squared greatest common factor jumps right out at you, but I'm only going to extract the r squared. And the reason for that is here in a minute, we're going to isolate a by taking the square root of both sides. So I'm just going to factor out the part of the GCF that's a perfect square. So factoring out r squared, this leaves behind 2 minus cosine of alpha. Solving for a, we can take the square root of both sides, and we end up with the square root of r squared, which is r, times the square root of the other factor, 2 minus, 2 cosine of alpha. So this is an interesting connection between geometry and trigonometry. The relationship here is the law of cosines. Now, it's not absolutely necessary that you memorize this formula for the length of a chord. You can certainly solve that type of problem simply by applying the law of cosines, but it's an interesting relationship to recognize. Let's try example 2. It says, the pentagon in Washington, D.C. is 921 feet on each side. What is the distance from a vertex to the center of the pentagon to the nearest hundredth of a foot? Now, to visualize how we're going to solve this problem, I'm going to make a diagram of the pentagon. That's 5 sides. And I'm going to imagine this pentagon inscribed in a circle. So all of the vertices on that pentagon will be on a circle. Because this building is a regular pentagon, all of the sides are equal and all of the interior angles are equal. Now notice, we could divide this pentagon up into 5 equal triangles. We know that the length of this chord on the circle is 921 feet from the given information. Our goal is to calculate the distance from a vertex to the center of the pentagon. So I need this length x here. But because we're dealing with a regular pentagon, that means all the sides are equal, then these triangles all have equal sides as well. Now let's determine this central angle, we'll call it alpha. If I imagine rotating around all of those equal angles alpha, I will have rotated 360 degrees. So if we take 360 degrees and divide it by 5, we'll easily determine that the central angle alpha here is 72 degrees. 360 degrees divided by 5 gives me 72 degrees. Now, we could certainly solve for x by directly applying the law of cosines. But you might find that the chord formula that we just derived from the law of cosines simplifies our problem a bit. So let's apply our new formula. A, the length of the chord, is 921 feet. This will be equal to the product of the radius, well, that's what we're trying to find, we'll call that x, times the square root of 2 minus 2 times cosine of the central angle, which we discovered is 72 degrees. So to calculate x, the radius of the circle, or the distance from a vertex to the center of the pentagon, we simply need to evaluate 921 divided by square root of 2 minus 2 cosine of 72 with our calculator. In degree mode, we obtain 921 divided by the square root of 2 minus 2 cosine of 72, and this gives us, to the nearest hundredth of a foot, 783.45 feet. 783.45 feet. So now you have some inside information about the Pentagon building.